Hello and welcome back to another lecture from your favorite course, Organic Chemistry. And we are talking about carbonyl group. And we said in any carbonyl group, we have unsaturated carbon that it can go through nucleophilic addition reaction. And we practice adding water molecule to the carbonyl, and we got the hydrate molecule. Next step, we added alcohol, and we got acetal molecules. And now we are going to actually practice instead of using 2 mole from alcohol, we're going to use diol and again, get an acetal molecule, but the molecule that we get, because we are using diol, and it will be a cyclic acetal molecule. Now, as you see from the left side, that we started with a carbonyl group. I'm going to highlight the carbonyl group, and that one we're going to react it with 1 mole from diol. It has 2 oxygen that both it can behave as nucleophilic centers. And then first step, we get a hemiacetal molecule, and the hemiacetal that will go through a bunch of steps until we get cyclic acetal molecule. And I want to mention one thing that's usually like a hydrate or hemiacetal and also acetal molecules are not that favored. Not favored, that means the reaction always favoring the starting compound. But in any of this reaction, we make water molecules. If we can get rid of this water molecule out of the system, we drop this one, we can actually push the chemical reaction to the right side. Okay, so in order to favor it, try to get rid of water or dry water out of the system. Okay, now that we got cyclic acetal molecule, well, what can we do with that one, and what's the purpose of it? And is in organic chemistry, making a cyclic acetal molecule is a good technique to protect some functional groups while we want to run the reaction on another functional group inside the molecule. And for example, we have a carbonyl here, and this carbonyl group, I can react it with diol, and it's going to give me an ether molecule. And so how did I initiate the reaction? I added the H+, that's my catalyst. So I'm going to say this one, it will be the catalyst. And then I will subtract water from the system, and it will give me the acetal molecule. So I'm going to say plus H2O. Now, if I dilute the product, what do I mean by the dilute? If I decrease percentage of water, if I add water to the to the system and add a bit also acid, this time I can force the reaction to go backward. So how about this? Let's put an equilibrium sign between these two and say this: it depends to concentration of the water molecule or amount of water molecule, we can change direction of this equilibrium. If you want to get acetal, drop concentration of water, or if you want to get the ketone back, or you want to release this protecting group at the end of the chemical reaction, just simply dilute the reaction and add a bit small amount of protein or H+. I can use diol to protect the carbonyl group. And for example, in this case, I have a molecule that it has a carbonyl group, and also it has an ether group. And I want to run a chemical reaction in a way that carbonyl stays as it is, but the ether group, I'm going to turn it to an alcohol. Okay. Now, the thing that you need to plan for it, to worry about it, is that we don't want to do anything with the carbonyl group. We want to keep it as it is. But we know carbonyl group, it can go under, nucleophilic addition. And same as this center, forgive me, same as this center, because that center also, it has sp2 hybridization. And so both of them will go through a nucleophilic addition reaction. Okay. How can we protect the carbonyl while we are reducing the other side? Okay, and so one way is just add diol to it, and when you add diol, you will get such a molecule. And now from there, you can reduce this center, because that center, it has sp2 hybridization, while the rest, including, for example, this carbon, it will be sp3 hybridization. Well, it used to be sp2. Let's go after this one. So first step of the reaction is going to be protecting the carbonyl group. So the carbonyl group now turned to this technically ether molecule, and the ether molecule, the functional group still is there. That part is there, and now is accessible for nucleophilic addition. Nucleophilic addition is not going to happen there on this carbon, because that carbon is saturated. It has sp3 hybridization. Okay, so next step, I'm going to use a reducing agent. A reducing agent, I can use aluminum hydride. And so lithium, aluminum hydride, it can be one of it. If I put lithium, then I don't need a negative charge. But this molecule, H, it has negative charge, okay? And we call it hydride. So that's going to be technically our nucleophile. Now, I go with lithium, aluminum hydride. I will add this, and one of the agents, it will go after this center, and it will give me such a species. Give me. So if we add H minus to it, that's going to be the nucleophile. Oxygen, it will take one of the double bond, it will take the double bond, and the 2 electrons sitting on the double bond, they will show up on oxygen. And oxygen, it will have 3 lone pairs. That means it will have a negative charge. The other side, we're going to have H here, and this one, it will be OR. And remember, this one, it has 2 lone pair. Okay, next step, okay, what I'm going to do, I'm going to add, again, I will add excess from lithium, lithium aluminum hydride. And next step, this is going to happen. This lone pair, it will come back to be shared with carbon, while OR, it will leave the system. Okay, so what do we get? Okay, let's say we're going to add this one. Next step, I want to show you like all the step one by one. So I get such a molecule. And, or maybe I should write here. Plus, I got OR. Remember, the solution is basic. And because it's basic, we can have species with a negative charge. Okay, next step, I'm going to add lithium, aluminum hydride. We add excess of it, so that means we have plenty of it inside the solution. And again, we're going to have attack technically this center. I get O with 3 lone pairs. It will have a negative charge. Now I have H there, and I just added another hydrogen. Okay, now this carbon, it has sp3 hybridization. Okay, now what will happen with the O minus? Okay, I'm talking about this oxygen. This is the time that you will introduce the, like a source of acidic H. So we don't add acid until we are sure the reaction almost done, and then we will add source of acid to the reaction, and that's going to give me O attached to hydrogen. Oxygen, it has 2 lone pairs. What else? I have hydrogen here and another hydrogen there. So this carbon, it will be a primary carbon, and it has a functional group for OH. So I'm going to say I got a primary alcohol. And this is the way, like we can turn the ester group to alcohol. Now, you can, this process, while, like you already neutralize a negative charge, you turn it to OH. If you have excess from that, protein, and also you have water inside the solution, you can reduce, you can release this group and turn it back, to a carbonyl. So the last step, again, is going to be just simply adding, excess of water in the presence of H+, and that's going to release the protecting group. And this one, it will go out of the system, and it will give us such a molecule. I'm not going to write all the steps, how to release it. And here also we have an OH. So that's going to be a primary alcohol. And I managed to release this group. OH or diol also, it will be recovered. And this is going to be end of the chemical reaction. Okay, so we know